Okay, good morning. Here we are, second week. Well, I'm sorry, second class. Still the first week of the second half of the semester. I hope everybody's doing well. I hope you're getting. I hope you're getting settled in. I know that it's a big disruption in everybody's life. You may notice that I have succeeded in figuring out how to do a virtual background. I have many wonderful choices here, mostly pictures that I have taken. For instance, that's a picture I took in Florida, but I'm going to stick with one of my favorites here. This is Mount Norris Scout Reservation. That's the place where I usually spend a lot of time during the summer. That's literally Mount Norris. It's in northeastern Vermont. And I guess if I stay closer to the camera, my head does not disappear. That's weird. I could just turn it off, but I'll leave it on for now. All right, here's what I want to do today. First of all, I had a good question raised, which was when will I get stuff posted to Moodle? And the answer is to try to get to that either this afternoon or tomorrow morning. And that will be the PowerPoint and the hopefully some class recording. So here's what happened. I did some class recording the first half of this week, and I went to go take a look at it, and it said the administrator has turned off access to the cloud recording. So I think we broke the cloud recording. However, I'm recording this, and I am recording it locally. So I'm recording it on my computer here, so that I can then turn around, and I'm just going to see if I can double check that that is happening. It is indeed happening. So it's being recorded here as a an M4A file or an MP4 file, which I can then upload to my YouTube channel and put it'd be an unlisted video, and I would put the link in Moodle. So that's the plan. And that also, there's some caveats with respect to that, but I think when I do that, it will also go up and be closed captioned, because I know we have at least one person in the course that needs closed captioning. Okay, so that said, here's the plan for today. I went through a PowerPoint on lists and how lists work. I spent pretty much the whole last class going through that PowerPoint. My plan for this class is to now go through and do a whole bunch of work with lists, but we'll do it in idle. And so basically going to go through and demonstrate a bunch of things that you can do with lists. So for that, what I have is I have a PowerPoint, and I have an idle session open. The PowerPoint really just contains a list, kind of meta, a list of things I want to do with lists. So without further ado, unless there's any questions, and feel free to use the chat if you've got any questions. I'm going to try to arrange my screen so that I can see the chat and the list of things I want to cover, and the idle session. Any questions before I start? Nobody? Bueller? That's probably before your time, right? You can't all hear me, right? Just nod.
Yeah.
Thank you. Somebody responded. It's a quiet group. So the question, do we still have quizzes every week? And the answer is no. There are assignments. There are going to be some quiz-like things that are going to pop up. There'll be quizzes on Moodle next week, but they're not going to be like where you come into class and you do a quiz. That I recognize that, for instance, we have about half the class here. Now, some of that's probably people who basically have said, I'll just watch the recording or look at what Dr. McCollin posts in Moodle. That's fine. But I've also talked with students who, for instance, they got home And one of my students, because his work study job on campus, or his job in Plattsburgh, he couldn't do anymore. He got home and got a job at a grocery store, because grocery stores are still open and they're looking for people. And so I recognize that you may not be able to keep to the standard course schedule of being associated here with this every day from every Tuesday and Thursday from 9:30 to 10:45. I get that may not be possible for some of you. So to that end, what I'm doing is I'm not taking attendance. I'm not really doing a lot of things that are going to be synchronous, if you will. We may do those things I'm calling super quizzes. I may ask those to be synchronous, but I will be, I'll be flexible with people if people have a reason that they can't do it in that time slot. My bigger concern is that the half of you that I don't see here, that some of them may have just given up, and that really worries me. I know, because this class is mostly freshmen and sophomores, you don't know each other that well. But if there's somebody you know in the class who is not engaged, if you have a friend from the school who has gone home and is either just watching video games or is just sitting in their room, please reach out to them. Let me know. I can see what I can muster. I think the counseling center is almost overwhelmed, but I will still indeed reach out to them. So yes, the plan is, I had a question here, the Tuesday, Thursday live Zoom meeting, so far so good. If this is working, it's working, and we'll keep doing this. If I get a lot of feedback that it's not working, I'll pre-record stuff, and then we'll do it that way. In which case, this would look more like an office hour session, where I would pre-record the stuff for next week over the weekend, post it to Moodle. You could then go watch it at your leisure and do whatever I put in for exercises, and then I would come here at this time just to answer your questions and demonstrate stuff to you. So as I said, I'm trying to be flexible. I'm basically looking at every week is a new experiment. Okay. Any other question? Any other questions before I dive into? Let's try to go do the other thing then. I'm going to do screen share. I'm going to share my screen. Doink. Okay, that goes away. I can bring up the chat. There's the chat. There is the stuff I want to go through. There's the chat. And then this, I'm going to put this down here. Okay, you should see my screen. You should see over on the left, you should see a demonstration. In idle, it says, so these are things I want to demonstrate. And then on the right, you should see the idle session. Okay, let me just make sure I'm at the bottom of this. There we go. Okay, so here's what we started. We started with this idea that we could create a list, and we could do it this way, right? And we can ask, what is that, right? And it will tell us that it is a list. That there's this pretty cool thing that we haven't used a lot called type, that is a function that returns what something is. Now, we can also say that we have another list, and we can do that using a empty brackets. And now we have two lists here. Now, if I create a list, okay, that's my list. Now, if I create a string, there's my string. Okay. So let's say I want to take every other element of the list, and I want to take every other element of the string. You see how that worked. Those are two slices. So what I just did is I sliced both the list and the string using the same slicing operation. The slicing operation I used, if you notice, if you remember, here, let's do this. Start equals 0, stop equals length of t, and I'm going to use the word stride is 2. So t of start colon stop colon stride. Right. With slices, we talked about this before, I can omit an element, right? If you notice there, I omitted the stop and it defaulted to be the end of the list, the length of the list. Now I can do this differently. I can say that the stride is 3, and I can say, right, in which case I get every third element. So what I'm showing you there is what I want you to take away from that is that the way that range works and the way that slicing work are the same, and the way that slicing works is the same for strings and for lists. So for example, if I said for I in range, length of t, whoops, that's not what I wanted to do. If I say for I in, for an I in range 0, length of t, 3, print I get the same 3 numbers, right? So this and this, right? These work the same for the range function, for strings, and for lists. You only have to learn that once. Learn that once, and you've got it for all 3 of those things. Okay, so we can slice a list. We can slice a list exactly the same way we sliced a string. So far, so good? I can't tell you how hard it is without being able to see you. I miss all of you terribly because when we're in class together, I can see you. I can tell. There are a number of you. I can tell if you know what I'm talking about or if it's gone over your head. And I just don't have that right now. So we'll do the best we can. Okay, so this is my list T. We talked about the ability to do 2 different things, right? I can do t.append, and if you notice, right, what popped up there is it said append an object to the end of a list. So I'm going to say I'm going to append 9 to that list. Now, if I say t.extend, notice there's a real big difference here. It doesn't say object, it says iterable. And it says extend list by appending elements from the iterable. So if I take and extend something, I have to give Python something here that it considers an iterable. Well, let's see if a string works. How do you think we knew that a string was going to work? I guess all of my questions are rhetorical questions now because there isn't really the feedback. If I take a string and I set it equal to sad, okay, can I slice that? That's an indication that it is an iterable. So if I take and I do an extend, okay, and I want to extend this, I need something that is an iterable. It means something basically that I can slice. So I can also, I could say here that this will be a list. And if you see here, what happened is I extended it by a string, and it took each element of the string and it added them as individual new elements on the list. And then I extended it with a list, and it took each of the elements of the list and it put them on there. Now let's compare that. That's a good question. That didn't change the string because the original string, right? The original string is still sitting here. If I do t.extend and add s to it, there is t and there is s. I didn't change the original string in any way. What I did is I copied the elements out of it. That's a good question. So let's say I'm going to go back up to, I'm actually going to say t, I'm going to go back and reset t. To here. Okay, so t.extend 10, 11, 12. Okay, so there's t. Now t.append 10, 11, 12. There's t. So do you see the difference there? This is what the extend did, is it unpacked, it unrolled that list with 10, 11, and 12, and it stuck each element on the end of t. T.append took each element and stuck it on the end of t. Took the entire thing and put it on the end of t. So this appended it, and this description for extend tells you exactly what's going to happen. Because if you notice here, it says extend list by appending elements from the iterable. In other words, it takes each element of this iterable and it puts each of them on the list as a new element, as opposed to t.append that appends the object, whatever I put in here, to the end of the list, which is this. So far, so good? You following me? All right. So let's take a look here. Let's see. Let's go with, what is the length of t? T has 13 elements. So if t has 13 elements, remember they're numbered 0 through 12. So t of 0 is the 0, and t of 12 is that last one. Now, if I say delete t of 12, I just undid what we did before, which is the append. This is an indication. So back to your question, Joe, about changing things, right? This is a case where because the list is mutable, I was actually able to go in and delete an item off the end of the list. I changed the list. This is different than if I had not changed the list. This is different than a string. I can't do that with a string, but with a list, I can do that. I can go in and I can say delete t : 2, and I just deleted all of the even, I deleted all the even elements, not the even contents, notice because the 10 and 12 stayed, but I deleted elements number, the elements numbered 0, 2, 4, 6, 8, 10. Right, so I deleted t of 0, t of 2, t of 4, t of 6, t of 8, and t of 10. Because I happened to have removed 9 at some point, or I never put 9 on it. But let's try, where did I reset t? Here we go. Well, let's do this, t.append, let's do t.extend 9, 10, 11, 12. Right, so there's T. Now, if I do the del of T, T colon 0 or 2, if you notice, I only have the odd elements left. Now, I could go here and I could say, let's delete 2, 2, 6. Right. And what I did is I took the elements 2, 3, 4, and 5 out of that. That's because I can alter a list. A list is mutable. Okay? So now I'm going to try this. We'll do t.clear. That emptied it. Again, something that you can't do to a string or something that's immutable is actually literally just wipe out the contents of it. Oh, I'll do something better. How many? Some of you have probably typed that before. I don't know. That was one of the things that they made us learn. That was a practice phrase when I took a typing lesson. Hunter, yes, floats can be in a list. I'll show that in a second. But let's do this. Let's do now s.split. And if you notice, if I do that, because strings are immutable, that did not change s, but I can say t equals s.split, and now I have a list with all of the words in the string. Because what it did is it split it on a particular character. Let's try something a little different here. Let's try this. Let's split on the letter E. Is that weird enough for you? If you notice, what it did is because I told it I wanted to split on the letter E instead of a space, the space is the default. I said split it on the letter E. It actually went through and it used E as the separator, and it removed all of the E's. There actually is a feature, I don't know if it's still there, but there used to be a feature in Unix where you could actually change what's called the internal field separator. When I was in college, we did that to a friend of ours, and we did this so that none of the commands they tried to enter worked. And then nobody could figure out how to undo it, and we had to get the sysadmin to fix it for us, and he wasn't happy. But we all worked for him, so. I know, it was cruel. It was kind of fun. The guy we did it to is actually a really good friend of mine, lives in New Hampshire. He and I have been friends for 40 years. So, but yeah, if you imagine if you changed your command line on Linux so that instead of parsing arguments on spaces, it used the letter E, it's very hard to make anything work anymore. All right. So that's the split. Now, we also have the possibility of doing a join. So let's take this U and let's do this. Let's say E.join U, and look at what happened. We were able to put the string back together by telling it to take the list we created, and everywhere there are two elements of the list, put an E between them and join them back together. Now, I mean, I could do this, right? This is an interesting one, though. I want you to realize the difference here, okay? Both split and join interact with lists. They are, however, string operators. Right? List object does not have split and join. Split and join are string operators. Split takes a string and turns it into a list. And join takes a string and creates a new string using that string that you gave it. Right here, we gave it the letter E. And it says, take the letter E and create a string that is made from this list U. And because strings are immutable, right, we have to save that somewhere. Neither one of these alters a string in any way. Doing good so far? All right. Let's so again, here's my T. I can clear that. And if you notice, right, the help that pops up in idle, right, it says clear, remove all items from the list. Boom, they're all gone. Now, I have this string. Let's do this. Let's say list, let's say T equals list, and let's pass it this iterable S. Now we've converted it into individual characters. Well, that's kind of interesting. Now we've sorted those characters. This is kind of an interesting thing. Let me show you what you can do here. So now let's say t.count. There are 4 of the letter I in that sentence. We'll go back and I didn't actually have to do the sort here, but the sort made it easier to see what was going on. But t.count E, right there, 6. T.count O, there, 9. This string definitely does not follow the standard table where E is the most common letter in most English text. But this is kind of cool because if I take a string, I can convert the string into a list. Once I do that, I actually have a list that has all the individual characters. If I use split, I can convert the string into a list where each of the elements is a word. These are actually really powerful if you want to do text analysis. So for instance, if I take a string and I convert it into a list, I can then actually go and use something we call a dictionary, right? I could count how many of each letter there are. There's a question is, what is S? S here was a string? Is that what you mean? Okay, cool. So I'm going to make a note of that because we will come back. When we do dictionaries, I'm going to do this. We'll do letter word frequency when we get to dictionaries. It's funny, teaching this in a different way than I usually do. I'm getting a lot of new ideas, things I would like to do. So, but what I'll demonstrate when we get to dictionaries is we'll take something like this, like these, and we'll use a dictionary to count how often various words and letters occur. And you might be thinking, well, that's kind of, yeah, who cares? I'm sure a few of you are probably like, why would I care? Well, it's actually kind of interesting because there has been some really interesting, believe it or not, text analytics done on things like Shakespeare and word usage and ancient texts and things like that. And Python is used for a lot of that kind of work. It's not all machine learning stuff, but it's actually, how do you count the total amount of letters in S? Oh, well, let's look at S. So here is S, right? Actually, if I want to know how many letters in S, I can just get its length, right? And the length operator works for both lists and strings. And since I made a list out of the string, they both have the same length. They both have 68 elements, right? Does that help you, Maggie? Cool. Okay, so where are we at? We were at there. Actually, length was the next thing I was gonna talk about. So there is the length operator, and I'm shuffling some papers here because I just want to get to. There's some examples I want to use. Where did that one go? There it is. Excellent. Okay. So the length operator is actually really useful. I don't know. Let me try this. I'm just curious. The length operator, unbeknownst to you, right? Range returns an object which is an iterable. We don't. To you, it's indistinguishable from a list of numbers, but it isn't actually a list of numbers. It's a special thing called a range object. But it has a length. And just a tiny little bit of foreshadowing. This is kind of a cool thing. When we get to object-oriented programming in a couple of weeks, it's actually the case that you can write your own length function for classes that you create. You can create your own object, and you can create your own length, and you can count the length pretty much how, calculate the length pretty much however you want. All right, now I want to introduce you to something you absolutely haven't seen before. So I'm going to go back to our simple T that's got just the sequence of numbers, because this is an easier place for us to see this. So this is T, right? Now I'm going to do something cool here. So okay, how many people's minds are blown? What I actually just did is I took a list T, okay, and I said T of 2:3, right? T of 2:3 is just the element 2. And I put T of 2:3, which is the same as T of 2. I put that on the left-hand side of an equal sign. And then I said, replace that with this list here. And what it did is, I got ahead of myself. I did two different things here. I got to clarify this so that you can see what happened here, because I just did two different things that are kind of cool. Let's go back up to this one. Let me walk through this slowly. So here's T. Now I said T of 2:3, right? T of 2:3 is a slice. And I said, I want to insert a slice into this element, or into this list. So this actually is doing kind of the equivalent of an extend. You notice here, we replaced 2 with a list. Now let's go back and do this again. And I'm going to show you what happens if I do this. Do you see the difference? There's a difference in behavior here. In this case, I said, I want you to replace a single element with this list. And it replaced that single element with a list. Here, I said, I want you to replace a slice, which is possibly more than one element. It isn't necessarily, but it possibly is. I want you to replace that slice with this list. And what it did is it said, I will insert the elements. So let's just put it this way. If I put a slice on the left-hand side, single element is the same as append, is like append. Slice on the left-hand side. Multiple elements is like extend. Austin, we'll get to that in just a few minutes. That's actually, if you look on the left-hand column of things I plan to demonstrate today, I have lists in a list. Okay, so let's try this one. I'm going to say T, I'm going to go back to this. I'm going to go here, and now I'm going to say T I'm going to say this is equal to I got to get the number right here, because otherwise I have a problem. I have to make sure I have enough of these. T of colon 2. So this is going to, I need 1, 2, 3, 4. Let's do it. I'll do it this way. 1, 2, 3, 4. Get this right. Nope. I needed 5. I need 5 of them. There we go. Okay. There we go. So here I actually said, I'm giving you a list with 5 elements. I want you to replace every other element in this list with those. Now, as you noticed from the error I got, if you do this, you have to be really careful. You have to give it exactly as many as you need. Again, that's the sort of thing you could actually write code to do that. You could even, what you could do, this is actually a kind of interesting way of doing this. Let's, I'm going to try this. So let's say length, we'll go back and we'll restart T, right? I'll say, what's the length of T? What's the length of T of colon 2, right? Those are the elements I need to replace. So now I will say X equals X, and then I'll say X equals X times 5. Now, oh, because it was a string. X equals X. X equals X times 5. There we go. And now I can do T of colon 2 equals X, and it will work. All right, let me step you through what I just did there. I started out, I said I want, let's say I have this T, and I want to use a slice to replace every odd number or every even numbered element with the letter X. Well, first I have to ask myself, how many of those are there? Well, that's easy. I can check that. Then I can create a list, right? And I think I can do it this way. There you go. I can now combine that whole thing into one operation. Equals. And there you go. Okay. Let's back up a little bit, because what I just did is like one level higher than I actually wanted to get to today, but it actually demonstrated a bunch of different things here. Let's look at what we just looked at. 1, we had a slice on the left-hand side. 2, we had using a stride for the slice. We must have the right number of elements, right? 3, we can use splat to repeat a list just like strings, right? So for instance, S equals X times 5, set, that created a list. What did I want here? I wanted, where did I go wrong with that? I can take a string. Why did I get a list for that? Okay, hold on. There we go. Because I did it for an individual object, it created a string. All right, so, but I can use the splat to repeat a list, okay? And then I used the length operator with a stride to get the number of elements needed. And what I ended up with is this kind of fascinating little piece of code right here. Oh, that's an, well, you know, actually, so that's a good, hold on a second. Let me just see here. I should be able to do this. So at the end of class, before I close this, someone just asked me if I can put this whole idle thing into Moodle. And what I can do is I should be able to save this session, and we'll see that works. And we'll see if that works, because then you could be able to open this up in an editor and go through it. That's a really great suggestion. Thank you. Okay, now there's this is the thing. Lists are really incredibly powerful, and I just want to tell you, I got a bunch more to go through with lists here. So I'm going to take just a break from that for a second to point out that one of the things that you will see with lists is there's all of this power, and sometimes it's hard to know how to do something or what to do. And one of the answers I got to give you is there's not always a right answer on a way to do something. There's a lot of ways you can do it, but not necessarily one or another that's correct. However, lists are really the most powerful tool you have in your toolbox with Python. There are other, dictionaries are very powerful, tuples are very powerful. Lists are really the king of the hill. They are the number one thing you use in Python are lists for collections of data. Okay, so now let me, I want to get to, where did I put my notes here? That is it. All my pages got out of order here. There it is. Okay. Let's look at another one here. So let's go back and we will reset our T here. Right, so there's T, right? Now, because lists are mutable, we can actually insert and remove things from lists relatively easily. So let's try this one, insert. So now, notice here it says, insert an object at an index, right? And notice it says before the index. So I am going to insert the letter A at location 2. Oh, sorry, I did them backwards. It's index first. 2A. So if you notice there, it inserted the letter A in front of 2. Let me go back and just make sure we're clear on something. Here's the length of T before I did that. Here's the length of T after I did it. Notice it did not overwrite anything in the list. What it did is it opened the list up, right? And it put something new into a spot in the list. Like, that's how insert works. Interestingly, Python is actually pretty forgiving with insert. So let's say the length here we said was 9. So I'm going to say I want to insert this in position 35. It says, well, you know, that's greater than 9. So I'm just going to put it at the end. Right? So that's a that's one positive thing, because there's a lot of places where Python is pretty persnickety about stuff, but this isn't one of them. All right, let's go back and redo this. Now let's try this. T.insert at position 2, A, B, C. Okay, so this is an iterable. Here's your question. Do you think this is going to behave like append or extend? And I'll give you a clue. Does insert always put the variable in front of the object? That's so that it always inserts in front of the index that you give it. Let me do this first, and then I'll show you. So first of all, this behaved like append, not extend. That's what I wanted to show you. But the other question that I got's a good one, and let's do it this way. Let's set, so there's no question about this, because the way I was doing it, the index matched the contents, which may make it look like it's using the contents for it. So there's T. Now, if I say T.insert in position 2, X, Y, Z, right? You notice there, it inserted it in front of index 2. It's not the content. It's not the item. It's the index, right? And as it says in the tip message, right? It says insert object, that's this, before index. Got it? So that's insert. Now let's try this one. T.pop. Remove and return item at index. The default is the last item. So if I do T.pop, it actually just removed G from the list. It popped G. If I see T.pop2, it removed that XYZ to me. This is all because we can modify lists because they are mutable. We are able to do all of this cool stuff with lists. And it is cool stuff, actually. It's kind of wicked cool. The stuff you can do, I know, does it sound weird that I think all this stuff is really cool? Powerful programming languages are a lot of fun to work with. Programming languages that are not powerful are actually still fun to work with, but they are more challenging. Python gives you a lot of tools. You have a very, very full toolbox of things you can do. So let's go back over a few of the things we've talked about, right? I have covered all of the stuff I wanted to do on this side. I've actually touched on a couple things over there, but right, we talked about how you create lists, slicing lists, extend and append, delete, split join, clear, creating a list from a string, the length operator, slicing on the left side of the equal sign, insert, and pop. I would imagine if I did a poll right now, most of you, your heads are swimming, right? I tell you what, you know, there's something we can do here that's that is harder to do in the actual class. And because I'm also getting a phone call, we're gonna take a, let's just take, hold on a second. I'm gonna try to turn this down. Okay, that's not working. I'm gonna mute for a second and we're gonna take a 5-minute break. All right. Sorry about that. And I told people 5 minutes, so we'll wait a couple minutes for them to come back. I was actually sitting there thinking about going and saying, let's take like a 5 minute break so that you can think about all the stuff that I just dumped on you. And then the phone rang, which is part of, you know, the joy of like live TV. For what it's worth, it's my wife. My wife is actually she volunteers as an EMT, and today is actually one of her days, her duty days. Um, and because she volunteers as an EMT, we get phone calls from the state of Vermont Health Department on various stuff. And as you may, with alerts, as you may imagine, we're getting a lot of those these days. That one was from the Vermont State Department of Health on contact tracing and changes they're making to that, which based on some information I've seen, I think they've given up on doing contact tracing because of the number of cases. Okay, give it about another minute or two for folks to filter back. I'm going to go on mute for just a minute. Let's figure on about 10:30 we will resume. Oh, feel free to message me as well. I'm going to get up for just a minute, but I will be right back. Hey, I'm back. Um, an interesting thought, and this is something maybe we'll talk about going forward. Is if we want to take a break during the class for just a couple minutes so people can get up and hit the restroom or just stretch their legs. All right, I want to get back to it though. We got a bunch left to do. So there were still some questions that were popping up. Oh, I didn't mean that. That's a pun. Popping up about pop. So that's exactly it. And Ian got it as well, which is pop removes an item. So let's just pop removes an item from the list by index. Okay. The pop call returns that. So I can say x equals t dot pop 0, right? X will contain A and T will contain the rest of the list. Now, we have another one that we can use, which is called remove, okay? This is a different one. Remove takes an item out of a list by value. So if I say t dot remove B, right? B is no longer there. But this is really important. Did you notice that when I did t dot remove, it didn't come back and say A, or it didn't come back and say B? If I say t dot pop 0, you notice it returned C to me. If I say t dot remove D, it does not return it to me. So to that question of the pop only removes things. It doesn't do a replace in location. We can do that, and I'll show you that in just a second. Well, there's no point not to do it now. Let's go back. Let's say that this was T. Let's say I wanted to replace the letter C with an X, right? Well, I can say t dot index. Notice here, when I say t dot index, it says, hey, return the first index of the value, and optionally I can tell it where to look from 0 to that last number that you've got there. That's 2 billion. That's 2 to the 31st minus 1. Remove is different than pop in that remove is by value and pop is by index. So remove will actually search the list for the thing you wanted to remove. Okay, let's go back and let's try this. So here's T. Let's say t dot remove X. Okay, this throws a value error. Okay, so the value error here is telling me that X is not in the list. Now, I can do t dot index X, and it will say it's not in the list as well. T dot index B will tell me that it's at location 1. T dot remove B will remove it from the list. So we haven't gotten to exceptions yet, but let me show you a little bit of what we can do here. So I can say try, okay, t dot remove X, except value error, print X is not in T, right? Because t dot remove X creates an error, and it creates something specifically called a value error. So a little ways down the road, we're gonna get to the point where we look at how to do this thing where we call it a try except, where we basically say try this command, and if it fails for this reason, do this piece of code. That's a little bit of foreshadowing. We will get to that. We'll get to that actually relatively shortly, but we'll get to that before the end of the semester, doing this stuff with exceptions. But let's go back and look at where we're at now, right? So we've got pop, remove, and index, right? So pop. So let's reset our T up here. We'll just do a little summary of this, right? T dot pop. By default, pop removes the last item on the list, and that is G, right? T dot remove works by removing it by value and does not return it. And then T dot index tells us where we can find something in the list. Good so far? This is a lot to take in. I totally get that this is a lot to take in. Okay, we're doing a whole lot right now, going through a whole lot of different things that you can do. There's another one we can do that's going to seem kind of obvious, right? T dot reverse just swaps a list end for end. Okay. And then let's try one other one here. Let's do T equals, oh, I know what I want to do. I'm going to go way back up here where we had this because I did demonstrate this earlier. Where did I set T to that? I just want to do this and I want to, oh, here we go. S equals this. T equals S dot split. Let's do T equals list of S. All right, so here's my list. Now I already demonstrated this, got ahead of myself, but let's say I want to know how many spaces there are in that. We can count how many times something occurs in a list. And we can count words as well here. We can say u.count the, right? And it tells us that there are 2 instances of the word the. Notice this here. This one here is the word the, and this one here is the word the. This contains the word the, but it is not exactly what we're looking for. This is counting list items that are exactly this string. So it didn't take this one because this element of this list is there, not the. So that's the count operation. Now let's see. So we had a question that was raised about how do we nest lists. So let's do this with the let's go back to our old favorite. Where did I go wrong there? Oh, I forgot an equal sign. Equal signs are important. There's T. All right, so what is T of 9? T of 9 is a list. What is T of 9 of 1? So this question came up earlier. Somebody raised it in the chat and they asked the question, what about a list inside a list? And the answer is you can do that. What you have to remember when you start trying to do this and you start trying to use like slices to take things out of this list is that T of X, Y, right? Which this isn't going to work, but I just want you to, T of X, Y really is the same thing as saying T of X, Y. So if I go up here and I say T of 9, right? That's T of 9. And I could say U equals T of 9. And then I could say U, what did I do wrong there? Oh, I typed the wrong one. So, and then I could say U of 1 is 10. So T of 9, 1 is 10, because we start with the T of 9. We take index 9, which is this list, and then we index the element number 1 that is in that. How many lists can you have in a list? So the answer to that is I've never tested to see. The answer is a lot. You could absolutely do a lot of lists inside a list. At some point, you start to struggle because it's keeping track of all the nesting that you've done. It becomes complicated. All right, let's see. This is where I'm going to want to come back when we meet next week. I am actually going to want, I'm just going to mark this for myself as where I want to come back to. So, do we have questions? How could I count either? So that would be, you would have to write a function to do that. So, oh, you know, and this didn't get raised, but let me show you something. For I in list T, or for I in T, remember that we did this, that you can index the items inside a list. Yeah, you could write a program that tried it until what would happen is the program would crash, it would run out of memory. Yes, thank you. Save the idle. So let's do this. Let's do a save as, and I'm going to save that in. I'm going to save that. Where did I put that? Oh, nope, there. Yep, there it is. Let's save it here. This is 26 March 2020 class idle. Now I actually want to do something. Want to go make sure. There we go. Let's go here. I'm going to go to there. There is that Python file. I want to open this with an editor just to make sure it's got in it what I expect. Boom! Look at that. It's all in there. Okay, that's good. I can post that to Moodle. Thank you for that reminder. All right, any other questions? So here's what I'm gonna want to cover next week is we're gonna try to finish up some of lists. I told you, do I play Minecraft? I do not play Minecraft. I used to play. Let me see if I can. Let me pull this up here. I used to play a program called NetHack. That is actually I played it as Rogue, the Rogue game. This was the game I used to play, and look at here, it says 1980. This is what I played on our computer mainframe when I was in college, and that's more or less exactly what it looked like. So there you go. That's about as I'm not really that into computer games, even like solitaire. Yeah. Anyway, I think we're about done for today. Remember that if you need help with office hours, I'm holding office hours. There's a Zoom session, and what it does is you go into the waiting room, so I can take you out of the waiting room one at a time and work with you. Also, remember, advising starts next week with everything nutty that is going on, as crazy as the world is. I think it's important to remember that we still have advising to go, and that you should make an appointment with your advisor in whatever method it is they are going to do advising. Okay, so I'm going to stop the recording and end the class, and I will talk to you all next week.